Today our program is called Ready, Aim, and Launch. We're going to be focusing on engineering, and we're going to be launching ping pong balls. With the engineering design process, what you're looking to see is you have a problem, you're looking for a solution to that problem. So you prototype something to find that solution. You have the opportunity to test this prototype to see if what you needed was met. And if it wasn't, you could go back to the drawing board, you could modify what you had to retest it again.
We were supposed to do it the other way around, but I felt that it would be a lot stronger if I touched the part that snaps onto the base.
Okay.
So I borrowed 2 more of the clothespins and I attached them here.
The way I look at engineering is you have the opportunity to test something and modify it. What is technology? When you hear technology, what are some of the things that pop into your mind?
Computers, architecture, all types of engineering, design.
Yes.
Technology is a byproduct of engineering.
Yes.
Technology ultimately makes our life easier for us.
It does. It certainly does. So give me an example of technology that you use every day.
My phone.
Your phone. What else?
Laptop.
Computer.
Computer, laptops. When you mention engineering, they're thinking bridges. Or if you mention technology, they're thinking their computers, their phones. So we typically start off our workshops trying to get them to realize that technology is not just something that's digital or electronic. It could be as simple as a pencil or a pen. That in itself has a history of how it evolved. And everything changed based on what we needed. What were the first writing tools?
Sticks.
Charcoal, sticks, stones. And that eventually evolved to what we use today, which is a stylus.
People want to come up with a solution, so there's a need for a specific product to...
No, you're absolutely correct. There's a specific need that we need. Everything from your shoes to the chairs to the tables to the lights that we have in here, they were developed, they were generated, they were made because there was a very specific need. The focus of today's workshop was to see how we can take regular household materials and construct something. So the students today constructed a catapult. After they constructed the catapult, we tested to see what restrictions the catapult had. Absolutely. All that potential energy is being stored at the base of the spoon. Is that the case for you? So then we constructed a trebuchet out of connects, and then we programmed a motor to see how many of those restrictions and limitations we were able to remove. In a trebuchet, you have a counterweight that's used. But in order to construct our trebuchet, what we want to do is introduce that computerized technique into this trebuchet. We had an engineering component where the students had just connects pieces and they had to figure out how to build their trebuchet. And it took them a while to get into the swing of things. It was really interesting to see that these kids never really worked with connects before. We were bringing that engineering aspect to it, and then you also have the computer programming aspect where you're programming this microprocessor to do what you want it to do. You're applying the same amount of force with the same amount of duration in the same technique every time in order to get that consistent drop. Is it possible to do that by using our hands?
You can measure the distance from the spoon to the floor or from the spoon to the point of release.
You're going to program a trebuchet that is going to be consistent each time it launches. All right.